We have earlier said that as the reaction takes place, carbon 4 oxide will be given out. And so the mass of the conical flask and the content will be reducing. So you now record at 1 minute interval the loss in mass and then plot a graph of loss in mass against time. And the following graph will be obtained. Calculate the loss in mass of the reaction mixture and plot a graph of loss in mass against time. Now, when you look at the graph, it passes through the origin, indicating that no gas will be given out when the reaction has not started. Now, the graph will have a very steep gradient at the beginning because the amount of reactant are still much. It's like somebody just eating. When you start eating the food will be there on the plate, very many. But as you continue to eat, then the quantity of food will be reducing. So also initially, the slope of this graph will be very, very steep. But as you continue the reaction, when some of the reactants have been used up, then the slope will become less steep. Now, when you come to this point precisely, the reaction is now complete. It's like a situation where somebody is eating a bland soup. By the time the bar finishes, you stop eating. But by the time the food finishes, you stop eating. So at a point like this, either the hydrochloric acid is used up or the calcium carbonate 4 is used up. And so at this point, the reaction has come to completion. And the graph becomes parallel to the time axis. So these are the observations from the graph. 1. The graph passes through the origin. Because no loss in mass right at the start of the reaction. Two, the gradient of the curve is steep when you still have the reactants in large quantity. The gradient of the graph is very steep